Right, the last example is a business application problem. At employees' monthly productivity M and number of units produced is found to be a function of number T of years of experience. So what are they saying here? They're saying the input is how many years have you been working for this company, and they are measuring an employee's monthly productivity. So how productive are you? How many I don't know, like Nike shoes are you making a month based on the years of experience? So what I'm thinking is, if a person has more years of experience, this person's monthly productivity will go up. Because wouldn't you say that an experienced person is probably more productive at their job than a new person? I don't know. We have to look at this function. But looking at how this function is a quadratic and upside down, look, this is a quadratic function with the negative leading coefficient. So what I'm seeing is this is a graph that goes up at first, and then it's gonna hit one point, and it's gonna go down. So what are they saying here? So they're saying, when a person starts, let's say Vivian starts the job, and she's working hard, and like by the time she hits the 10-year, she was getting good at her job. And then by the time she hits 10 years, she's like done with the work. She's ready to retire. She's ready to go. And then maybe her productivity goes down. So I think that's what's happening, okay? Because the shape of this graph is a quadratic function that's opening downward. A person's productivity will increase at first. It's going to hit the maximum point, and then it's going to go down from that point on. So what will happen at year 10? What will happen to Vivian at year 10? It's probably not year 10. But when that productivity hits the maximum, should we keep Vivian or should we fire Vivian? Because her productivity will only go down from that point on. That's not my decision to make. I'm just going to do the math for them. So let's see. For a certain product, a productivity function is shown below. Find the maximum productivity and the year at which it will be achieved. Hey, maybe you guys, we'll talk about that later. But let's go ahead and find the math for them. Let's do the math for them. So what I will do is I'll find m prime of t. Oh, bless me. If I find the derivative, I will get negative 4t to the first power plus 120t will give me 120 plus 120. What is all this? Plus 120. Okay, and 100 will just go to 0. Hey, I'm getting distracted over here. I see what's going on here. They're only letting Vivian work for 40 years. The maximum is 40 years. After 40 years, she has to go. Okay, all right. I'm going to find the critical value by setting this equal to 0, because critical value is where a relative maximum or minimum could happen. So that may be a point where it is relative absolute maximum or absolute minimum. So if I solve this, I will get 4t equals 120, t equals 30. Uh-oh, something will happen after 30 years of Vivian working for this company. Uh-oh. So now what am I going to do? I'm going to go ahead and find m of 0, m of 30, and m of 40. You understand why I'm finding m of 30? Because that is the critical value that we just found. Well, guess where I got the 0 and 40 from? These are the endpoints. You need to always check them, okay? So how productive is she when she first got hired, when she has 0 years of experience? Let's plug it in. She can't be that good, right? She's probably motivated. But if I evaluate this, these goes to 0. So she can make about 100 iPhones. Okay, that's her productivity. I don't know what they are making in this company, but her productivity is 100 units. All right, what about at 30 years? For this one, I will need to use a calculator. If you can double check my numbers for me, that will be great. I'm going to go ahead and type this into my calculator now. I got 1900. And I know you will email me after watching this video if you get a different answer so that I can fix it. But guess what? After 30 years of working, Vivian's productivity increased from 100 when she first got started to 1900 per month. So that's very good. She got some experience. Now what? Let's go ahead and see what will happen to Vivian at year 40. I think I know what's going to happen. I think it's going to be lower than that. Let me change the 30 to 40 on my scientific calculator. And the number is 1700. Hey, I think that's still good though. I think that's still very good. But what are we interested in? We're looking for the maximum. This is the maximum. Okay, so let's go ahead and give them the answer and talk about this. The maximum productivity is achieved in year what, 1900? No, year 30. When Vivian's working for the 30th year, her productivity is going to reach its maximum. And the maximum productivity is 1900 units. So what will happen? After 30 years, 31 year, 32 year, 33 year, her productivity will just go down. So maybe instead of firing her after 30th year, maybe we can give her some professional development, right? Maybe we can give her a raise or something. But this was a nice business application problem because you do care about these things. When is my employee going to have the maximum productivity? If you have a model that we can use to find these values. So that is it for this lesson. I told you 3.4 is going to be a short one. I'm going to be back to go over section 3.5, just couple more optimization word problems. But you are ready to start your My Math Lab homework 3.4 now.